And welcome, function folks. Lesson 5.5, modeling day one. We got a couple of days of modeling, and then we're going to call it a course, just about, except for that tiny little thing called the exam, but we'll worry about that later. Uh, Fairly big warm up. Got a couple of things that I want you to think about for the warm up, and this is the first one. This is just some practice with composition of functions. We've looked at a few times for A here. Remember, F composed with G at pi. This means for us to take G at pi and sub it into F. So one way to do that is, well, let's figure out what G at pi is, and it's sine of 2 times pi. And what's the sine of 2 times pi? Well, what's the sine of 2 pi? There's y equals sine theta. There's 2 pi. This is equal to 0. So this is f at 0. And so then I take that value and substitute it into f at x. Get 0 squared minus 4 is minus 4. Dandy. And then I just want to do the same thing again over here, except for with a different value. I take the value of f at 2 and substitute it into g, and I'm going to show you a little bit of a different style here. Instead of doing my kind of work in the margin, I'm going to do it right there inside the function. Watch, f at 2. Well, if I put in 2 for x, then I've got 2 squared minus 4. That's f at 2. And then I got g at 4 minus 4 is equal to g at 0. And then I can take out the 0 in g, or take out the x in g and put in 0, and I get the sine of 2 times 0, which is also, by that same graph, 0. Dandy. What's the point here? Well, the point is just to practice and remembering what composition of functions is, because that's the combination of functions we're going to be talking about today. The combination is composition. Also inverses, I guess. So here's the inverse. If I want to find f inverse, I'm going to write down f at x first, which is x squared minus 4. And then I think of changing the position of the inputs and the outputs, and then solving for the independent variable, solving for the for y now. Add 4 to both sides, square root, and we understand that there's actually 2 functions here, but we usually think of the inverse function as being one of the values or the other. Okay, great. That's the inverse function. And then for D, notice, I hope you recognize this by now. We talked about this so much this year. This is a fact you should know. F inverse composed with F is just plain old X. But if you want to see it long version, right, I've written it here, and you can pause it if you like. I'm going to go through it really quickly. F inverse composed with F. F goes in on the inside of the inverse. There's F at X. There was the inverse, right? We said the inverse was x plus 4, the square root of x plus 4, and then everything sort of folds up like a card house, and I'm left with x, right? Negative 4 and positive 4, square root of x squared becomes x, and it's all dandy. All right, number 2. More composition review, except for with fancier functions. For A, f composed with g at x. Again, it's the same idea, except for I'm left with a function, right? G at x is this rational function, and then I get this new weird looking function. I took out the x and substitute in what was in there for x, and I get log base 5 of a rational function, which is a bit strange looking, but onwards. B. G composed with f at x, and one thing that we saw and remembered was that these two aren't equal, right? The function composition is not commutative. I can't change the order. Uh, but let's just calculate it anyway. We were asked to. F at x is the middle thing. Log base 5 of x. And then in G, where there used to be an x, I'm going to put what x is equal to, which is log, and this is a bit of a mess, right? But these are the two new functions, and quite clearly these are different functions, right? They're nowhere near equal. Okay, dandy. So what's the point of B? Sorry, C. Which of the functions in A or B have x equals minus 4 in their domain? So notice here, I'm going to do C and then split it like this. For minus 4, we see that it's not defined for G, right? So when I put G at minus 4 isn't defined. And so when I put minus 4 in here, I have 0 on the bottom of a rational function, and so it's not defined, right? For x equals minus 4. Danny, notice that even if I put x equals minus 4 in here, it would also be not defined because I can't take the log of a negative. Well, what about 0? Notice that if I put 0 into f, that's not defined, but when I put g at 0, that's okay. And so is f at f composed with g at 0 okay? Well, let's have a look. Is it okay for me to put in x equals 0? It wasn't okay for me to put in x equals 0 into f because the log function's undefined. But even though I wouldn't know what it is, can I take the log of 1/4? Yeah, it's got to be positive, but if that's positive, this is okay. So x equals 0 is in the domain of the composition. Okay. Let's have the same argument over here for B. Notice negative 4. I put negative 4 in for f at x. F at minus 4 not defined. Not defined. So neither is g at f at negative 4. The inside function isn't defined, right? I put minus 4 and automatically that part blows up. Now what about x equals 0? Well, x equals 0, same thing. Because I can't take the log of 0. So f at 0 not defined. So neither is g at f at 0. So it didn't work in either here, but in this one, the 0 did work for the composition. All right. Interesting discussion about the domain of the composition function, remember. Interesting. Anyway, what's next? What's next? What's next? I think I've got another warm-up thrown in there. So I don't know if you have this on your handout or not, but this is kind of a review of the independent study that we did, the algebra of functions thing. Very similar. Is the composition of two odd functions even, odd, or neither? Well, how do we handle this yesterday? Well, basically all we did is we picked some functions and tried, right? Is the composition of two odd functions even, odd, or neither? Well, pick some, right? This is how we did it. What are some odd functions? Well, Maybe we'll try, this one's an odd function. We try and keep it simple, right? That one's an odd function. So is the composition odd? Well, let's see. G is just x, and then I take out the x and put in an x, right? Because the inside function is kind of boring. Is x cubed. Well, is this thing odd? So we suspect that probably, after one example only, that the composition of two odd functions is indeed odd. And we might try something else, and in the investigation we pounded them into a calculator and saw if the symmetry worked out and that sort of thing. Is this a proof? No, it's not a proof. It is not a proof, and you're not responsible for proving this, but just for funsies, I am going to prove this. Before we get into today's lesson, I will prove this at the beginning of part 2.